How often have you wished you could stop time, even just for a moment? This tantalizing idea has been a subject of thought and debate for centuries. Time, as we know it, is a continuous, unrelenting flow that governs our existence, from the smallest biological processes to the grandest celestial events. But what is time, really? It's more than just the ticking of a clock or the turning of the Earth. According to Albert Einstein's theory of relativity, time is a dimension, much like the three dimensions of space we're familiar with. But there's a twist. Time is tied up inextricably with those three dimensions, creating what we call the fabric of space-time. Just as we move through space, we move through time. But unlike space, we can't choose our direction in time. We're all carried along by the current, moving inexorably from the past through the present into the future. Now, if time is a dimension, you might wonder if we can manipulate it like we do with space. Can we stop it or even reverse it? This is where things get tricky. Einstein's equations show that the flow of time is affected by things like gravity and velocity. The more gravity or speed, the slower time moves. This is a proven phenomenon known as time dilation, but stopping time altogether? That would require manipulating these factors to an unimaginable extent. And let's not forget the practical implications. The processes that keep us alive, down to the cellular level, are all tied to the passage of time. If we were to stop time, we'd be stopping these processes too. The consequences, well, they wouldn't be pretty. So, stopping time isn't as simple as pressing a pause button. It's far more complex and intertwined with the fabric of our reality. Stopping time, it seems, remains a dream, a fascinating concept that for now resides firmly in the realm of science fiction. To understand why we can't stop time, we need to delve into Einstein's theory of relativity. This revolutionary theory, proposed by Albert Einstein in the early 20th century, forever changed our understanding of time and space. At the heart of Einstein's theory is the concept of spacetime. Spacetime is a four-dimensional fabric woven together by three dimensions of space and one dimension of time. In this fabric, time is not a separate entity. Instead, it's intricately intertwined with space, inseparable and equally affected by the happenings within the universe. Now imagine spacetime as a trampoline. When an object of mass, let's say a bowling ball, is placed on it, the trampoline dips, creating a curve. This is akin to how gravity works. It warps and curves space-time, causing objects to move along these curves. But here's the fascinating part. Gravity doesn't just affect the path of objects, it also affects the flow of time. The stronger the gravitational pull, the slower time passes. This phenomenon is known as gravitational time dilation. Yet gravity isn't the only factor at play. Velocity, or speed of motion, also affects the flow of time. According to Einstein's theory, the faster an object moves, the slower its time relative to a stationary observer. This is known as time dilation due to relative velocity. So, time, according to Einstein, is far from being a constant, independent entity. It's a dynamic dimension influenced by gravity and velocity woven into the very fabric of the universe. This understanding presents a formidable challenge to the idea of stopping time. To halt time, one would need to manipulate gravity and velocity on a scale beyond our wildest imaginations. In this framework, halting time would require unimaginable manipulation of fundamental forces. As we continue to navigate the mysteries of time, Einstein's theory of relativity serves as a powerful guide, reminding us of the complex, interconnected nature of our universe. But let's say, hypothetically, we could somehow stop time. What would that mean for us? Well, it's quite a conundrum. Imagine for a moment that the tick-tock of the clock ceases, the sun hangs still in the sky, and the world around you freezes. It may sound intriguing, yet the implications of such a scenario are mind-boggling. You see, time is not just an abstract concept we use to organize our lives, it's deeply woven into the very fabric of our existence. Biological processes, the ones that keep us alive, are entirely dependent on the steady march of time. Take the beating of your heart, for instance. It's a rhythmic dance perfectly synchronized with time. Without time, this dance would come to a standstill. The cells within your body, those tiny building blocks of life, would also cease their activities. They wouldn't be able to divide, grow, or repair. The orchestration of life as we know it would grind to a halt. Consider the world around us. The ebb and flow of the tides, the blooming of flowers, the changing of seasons. All these natural processes are deeply tied to time. If time were to stop, nature's symphony would fall silent. And it's not just the biological world. Even the fundamental physical processes like the movement of atoms and the transmission of light are governed by time. Without time, the universe as we know it would be frozen in an eternal stillness. So the idea of stopping time isn't merely a challenge of bending the laws of physics. It's about disrupting the very mechanisms that allow life and the universe to function. It's about turning reality as we know it upside down. Halting time isn't just scientifically challenging. It could disrupt the very essence of our existence. And while it's a fascinating thought experiment, we must acknowledge that, for now, and perhaps forever, time will continue to tick away, shaping our lives and the universe around us. The idea of stopping time brings us to a realm of paradoxes and quantum mechanics. Let's begin with the paradoxes. The concept of halting time instantly introduces a host of conundrums. Imagine if time were to freeze. What would become of cause and effect, the chain of events that shapes our reality? If time is at a standstill, can an effect follow its cause? Can anything happen at all? It's like the age-old question of the chicken and the egg, but magnified to a cosmic scale. These paradoxes challenge our fundamental understanding of the universe and how it operates. Speaking of challenges, let's dive into the fascinating world of quantum mechanics. In this realm, the rules of the game change. Particles can exist in multiple places at once, in a state known as superposition. They can be both here and there, both this and that, until observed. It's a concept that defies our everyday logic, but it's been proven to be a fundamental part of our quantum reality. Now you might think, well, if particles can do all these bizarre things, maybe they can stop time too. Unfortunately, it's not that simple. While quantum mechanics is full of surprises, it doesn't offer a straightforward path to halting time. In fact, the quantum world adds another layer of mystery to the temporal dimension. Time in quantum mechanics is a slippery concept. It's not something that can be easily pinned down or defined. Instead, it weaves itself into the fabric of quantum events, becoming an integral part of the dance of particles. In essence, quantum mechanics doesn't give us a magic button to stop time. Instead, it presents us with a deeper, more complex picture of what time might be. It takes the enigma of time and adds a quantum twist, leaving us with even more questions to ponder. Quantum mechanics doesn't offer a clear pathway to stopping time, but rather deepens the mystery of this temporal dimension. So, can we stop time? As we've journeyed through the nature of time, Einstein's theory of relativity, the practical implications of stopping time, paradoxes and quantum mechanics, a clear pattern has emerged. Stopping time, while an enthralling thought, is a fantastical concept that defies the laws of physics and challenges our biological existence. Einstein's equations showed us how time is intertwined with space, affected by gravity and velocity. To halt time would mean manipulating these fundamental forces, a feat beyond our current capabilities. From a practical standpoint, freezing time would disrupt essential biological processes, resulting in catastrophic consequences. The concept of stopping time introduces paradoxes that challenge our understanding of cause and effect. Quantum physics, with its state of superposition and puzzling phenomena, does not give us a clear path to stop time. Instead, it deepens the mystery of the temporal dimension.